everybody, this is Mike for Faraday Research. It's Saturday morning here, and I'm going to do another road trip. So I'll be heading to Mississauga, Ontario. They have an electronics store out there. Don't have to go to the surplus today because the stuff I'm looking for are small components and stuff like that, and it's a lot closer to home. So I hope you guys can join me for the road trip. Should be a lot of fun. And then after that, I have to do some grocery shopping. Faraday Research also has to eat too. So yeah, so leave my family at home, let me get my stuff done, and yeah, so stick around and I'll show you what's going on today on my road trip, what parts I'm going to be getting. All right, stick around. Okay guys, yeah, we're here at the electronics store here in Mississauga, Ontario, and we're at Sale Electronics, and I'll be picking up some of the components I need for the build. And thanks for sticking around for the road trip. It seems like to be a common thing now. Every Saturday I'm on the road looking for components and stuff like that. So yeah, obviously I'm working on this new Adam's motor and pulse motor design, and I'll be showing some more stuff later in the day today, what I've worked on, and some of this important stuff that I found out with the motor. And yeah, I've got some interesting numbers that I've been playing with, and yeah, so stick around for the next segment and we'll do some shopping here and get what we need. Hey guys, I just finished the shop here, and so yeah, I picked up some stuff for the Adam's motor build. So you can see I bought this project box. So the whole circuitry, everything's going to go into this box. It'll be nicely packed inside. The wires will be sorted out, and yeah, it's got mounts for the box. So yeah, you know, I'm going to use this. This costs about $20 for that. And something else I picked up that was really interesting today: copper tape. I don't know what the heck I'm going to use it for, but I have some ideas that might actually help with my build using copper tape. So yeah, this was like $20, and I got a couple of full weight bridge rectifiers. I got some LED lights, and what else did I get? Yeah, LEDs. I got a whole bunch of stuff here in the bag. Yeah, basically just small components today, not really big components. So yeah, I'll be putting that stuff together tonight. I'm going to rewire the box and attach that to the motor. And yeah, we'll clean things up a bit, and I won't have so many wires lying around and stuff like that. So yeah, you know, I killed a few bucks today on, you know, just the simplest electronic components. Everything's getting so freaking expensive now. Unbelievable. Some of the prices of electronic stuff now is just going through the roof. But anyways, it is what it is. You know, this is all in the name of science. So yeah, yeah, we're gonna head home now. I gotta do shopping. I need some food, and then later on today, I'm gonna be doing some work on the Adam's motor. And yeah, I'll put everything together and I'll show you guys what I've come up with. And yeah, so we'll stick around for the next segment, and we'll be right back. Hey everyone, welcome back to Faraday Research. It is now Sunday. I decided to hold off yesterday after I did my road trip because I wanted to do some work and show you guys more or less what I've been up to. Yesterday I got a little busy with family stuff, so you know how it goes. So I had to put it off till today. But anyways, yeah, I went on my road trip. I got some components and parts, and one of them was I got a power box for the build of my Adam's motor build. So I want to show you all the stuff that I've done up to this point. Now I'm getting to the point now where I can start doing experimenting with my lens-free coils that I have here. I'm going to show you what I did with the power box and the wiring and all that kind of stuff. If you haven't subscribed to the channel, bottom right hand corner. Also at the end of the video, give me a thumbs up if you like the video, or any time during the video. Also too, I'm starting to make a presence on Rumble. Okay, there's a new multimedia. Well, they've been around for a while, but I'm going to start pushing my stuff over there because there's less censorship and a little bit more freedom as far as what I can do and what I can show and what I can't show. I've had 2 friends now, actually 3, that have actually gotten the boot on YouTube. So I want to prevent that from happening to me. So a lot of my videos now are going to start moving over to Rumble. So please check out Rumble's site there and subscribe to Faraday Research RND and support me on that channel as well. So let's go over just some of the stuff I've done. First off, I bought the power box. So all my components now for the Adams motor are in here. I got the terminal block, I got my switches, I got a light to show that I'm using a power supply right now with just one of these wall plug things to actually power the reed switch. Reed switch and the fan, and that's pretty much it. That's all that this does. The 2 wires at the back, I've put connectors on it now. These go to your power source, your battery, or whatever you want to use. So I did that. I got also a kill switch here. If I want to shut the main power off for the Adams motor, I can do so right here very easily. And I also installed inside a full weight bridge rectifier, which I'm going to be using for this setup here. If I want to charge capacitors, all the power that comes off here is AC, and I'll have to put it through the full weight bridge in order to charge batteries or capacitors or whatever I want to do, or try feeding it back into the system, which that's going to be part, excuse me, part of the experimentation, what I'm going to be doing with this motor. So right now, thus far, I'm at the point now where I can start doing some science here and actually putting this motor together to actually generate excessive amount of power. So it's a traditional Adams motor design, okay, but with a few twists. Now, he used a rotary commutator, which he says is essential for charging batteries. Okay, I've gone to the modern version of that, and I'm using an automotive relay switch, which is in here behind the fan. I got the fan there. I technically don't even need the fan, but I put it there anyways just to keep some airflow going in there. And also the radiant energy has to have some flow going through the circuit. So I have a hole here on the side that I actually dremeled out. And so that allows me to have some air circulation throughout the power box. As far as the wiring, I'm going to take the top off here so you can actually see. So basically it's an Adams motor and an AC generator built into one. The Adams motor is actually creating the mechanical power that runs the AC motor. So now it's a 2-stage motor system, which I haven't really seen anybody else out there do it except for one guy. And he's been out there longer than me, probably 40 plus years he's been doing this stuff. He's the only other guy that I know of that's actually done like a 2-stage system. I'll take the top off here and you can see what I've done. So I've got the Adams motor wheel there, 6 magnets. Now I'm using lawnmower wheels. Now the last video you've seen, this wheel here was actually quite a bit larger. It was an 8-inch diameter, but I found it was drawing too much of a load on it. So I wanted to get the efficiency of the Adams motor up. Now, first off, instead of using a traditional reed switch, I'm using a 3D printer proximity sensor. They're way faster, way more responsive, and they're a lot more reliable. They won't burn out. Now, the way I have my circuit set up, it's completely isolated from the rest of the system, which is running off this power supply here that just provides 12 volts, nothing more. So I have to keep that isolated from the rest of the circuit. So opening and closing of the switch that I have in there, the auto relay switch, it's also running off of this. So this power block is running the switch and the proximity sensor. It's isolated from the rest of the system. If I don't do it, I'll blow the crap out of it. Guaranteed. And I've blown up many reed switches. So underneath here, this is one of the keys to my Adams motor getting the output that it is getting. Nobody's using them, and it's baffling me because the gains are so high with this. It's almost a no-brainer, pretty much a no-brainer. I got 3 Piezo electric transducers. These put the coil into harmonic resonance, and I know so is because of the huge amount of power gain that I get. If I wasn't getting huge amount of power gain, these things obviously are not doing the job. But when I remove these from the circuit, my high-end power decreases dramatically. So I use 3 Piezo transducers. They make it a little bit noisy. They are firing, and they are getting this coil. This has about 600 turns of 24 gauge wire. It gets it into harmonic resonance because the power gain goes, like, if I put it on an analog meter, it'll show about 5 volts going out. It doesn't show high voltage spikes, but true voltage, about 5 volts. When I add the Piezos, 3 of them, I'm hitting over 30 volts. From 5 to 30 volts, that's a huge power gain. Not only that, my high voltage back EMF also increases. This bulb is hitting about 200 volts, but because it's pulse DC, the bulb doesn't blow up. So this is kind of like the bleed valve of the system. So if I were to detach this, my Piezos are like ready to friggin' explode because they have so much back EMF going through it. So what I did was, if you can see it, I got those stereo hookup. So now I've hooked my coil up to it. So if I want to swap coils out and experiment with different coils, I can do so very easily now by just pulling these 2 wires off. Boom, I can detach the coil. As well as the Piezos are also separated from the in these connectors here. So I could take them out, I can change stuff. Now I can do the science. I can actually work with this now. So, and now I'm going to be running the system with my lithium iron phosphate battery, which works fantastic. And yeah, so now I'm at the point where I got good wiring, I got good hookups so I can swap stuff out. I'm at the point now where I can really start doing the science. If you guys haven't subscribed to the channel, bottom right hand corner, also I have my email below. You can also email me, make questions, comments below in the description. Also, don't forget, become a Patreon. You can, like I said, I'm going to be moving over to Rumble. So check out Rumble. I'm going to be on that channel a lot more. I'll probably do teasers on YouTube, but the full videos are eventually all going to be put on Rumble. And that way you can follow me that way. I'm really starting to lose faith in, what's happening out there as far as censorship and stuff like that. So I kind of have to be prepared. I'm going to be buying a new computer soon. I need it because the one I have right now, this one here, is like on its last legs. It's about 6 years old, so I'll have to get a new computer, start downloading all the old videos that I have, and start transferring everything over to Rumble. Now, I'm also thinking about going on another platform called Brighteon. Brighteon's another good place. It has very little censorship there, and I highly recommend that platform as well. So this is what I've done. The wiring's a lot easier now. Everything's in the power box. It's all cleaned up. I'm probably eventually going to paint the damn thing because, I don't like the way the wood looks. It's just kind of messy looking, but that's not really a big concern now. I'm more concerned on the science that I'm going to be doing with this thing. So anyways, let's go around here. Let's put the wheel back on, and I'm going to fire it up, and I'm going to show a couple little demos of what I've been doing. So I'm doing this with one hand, so bear with me here. Balancing the wheel was a bit of a bugger too. That was not fun, trying to get it to run true. So the generator part is a 6-inch wheel. It's got north-south all the way around. And yeah, so now I can put these coils in proximity of the wheel, and I'm going to start generating power, which is going to light up this little... I've actually lit up a 12-volt power supply, a 12-volt light bulb, low amperage, and it does work. I'm still in the process of engineering these coils. So yeah, so what I'm going to do is I'm going to fire it up, and then I'll start generating some extra power with the top generator. So this, in essence, this is 2 motors, 2 generators in one. I got the Adams motor. I can take the back EMF that's lighting this bulb. I could hook this up to a battery system, like a off-the-grid power system, put it through a full-weight bridge. Boom, I'm charging a house. And because the amount of voltage I'm putting through, it'll allow me to do so. So pretty impressive right there, all on its own with the Adams motor. So I got a platform that's workable now. Now I can do a lot of swapping of stuff in and out. Really cool. So let's get this thing fired up. I'm gonna hook up the power leads here. Bear with me, I'm doing this all with one hand, which makes it that much harder to do. Okay, got that hooked up. Get this hooked up. I'll get my reed switch hooked up. Okay, so I got power, the light is on, the fan is going on inside. This is my main power switch here. Okay, if I spin it on its own, you can hear the switch going off. There is no power. The only power that's going to be fed into the coil system is coming from the battery, not this power supply. This is isolated. All right, it's just running the switch and the proximity sensor. So let's get it going. I'll give it a little spin. Actually, technically, I don't even need to do it, but all right. Let's get it going. This thing goes pretty quick now. I have to hook up my speed tack on it. Get everything dialed in here. Make sure I got my... Alright. Get her going at a good RPM. Alright, let's do this. Okay, I'm going to put this first coil up, just the one coil. I'm going to bring it in. I've already got power. Bring the second coil in. So you can see that this generator is now lighting up this light array. So I'm going to be experimenting a lot more with this. This is really cool stuff. And there's almost next to no lens effect on this. It's not slowing the motor down. That's the key to this system. If you can defeat lens law, you've won the game. They say lens law can't be beaten. I beg to differ. And look at the light. Look how much light I'm getting off this thing. Huge amount of light. So everything's really good. There's the Adams motor there. And then it's powering my AC generator. So right now, this is very low amperage, right? You know, I got 32 LED lights, and you can see how bright they are, fully lit. Now, I'm putting AC power. I haven't even put it through a full-weight bridge yet. So, you know what I mean? Like, I can adjust the coils. Now, here's the cool thing. Watch this. I'm going to shut it off, and this thing's going to continue to spin, but it's going to also continue to generate power. Watch. Okay, it's off now. The Adams motor is not working. It's still generating power. See? The motor's just winding down on its own. It's still generating power. So, we're at 15 minutes. This is a pretty good video, just to show you where I'm at. Now I got something really good to work with, easy to hook up, easy to swap stuff out and try it out. Different coils, different arrangements. I got a platform I could actually work with now. So, yeah, very, very cool. I'm very happy with what's going on right now. Like, look, it's still moving. It's still rolling. That's how well balanced I got this thing now. It's got a lot of inertia in that wheel. So I could hook up a circuit where I could run the Adams motor and actually shut it off for, say, 30 seconds and then turn it back on again and continue to generate power, because now I'm running on inertia power, like a mechanical battery, a flywheel design. That's really cool. So not only I can do that now, it also takes less power out of my power supply to maintain this thing generating power. So you can do it in cycles. Every 30 seconds, shut the motor off for 30 seconds, turn it back on for 30 seconds, turn it off for 30 seconds. This thing will never stop moving. As long as this is moving, this is generating electricity, usable electricity. So I got to perfect my coil designs. That's going to be in Patreon. I'm going to be working sometime this week on that, getting a schematic, and I'm going to post it on Patreon. I've been really busy because now I'm back to work now. So yeah, things have gotten extremely busy for me, and I'm always on the go now. But irregardless, I've done a lot of work in the last couple of weeks on this design. Give me a thumbs up if you like the video. My email and description, and all Patreon, PayPal if you want to donate. Become a member of my Patreon. Bottom right hand corner, you can subscribe to the channel. Share this with your friends. Get the word out. This is how stuff gets innovated. This is how stuff is going to be created for the future. So, you know, the future starts now. So we have some good electronics to work with. We have some good engineers out there now that are working on stuff. Myself, probably a million other guys are working on stuff like this. Share it, get the word out, spread the word. And yeah, we'll call it quits for tonight, and we'll see everybody soon. Take care for now.